Hi friends, I am Gokul. I am going to discuss on the topic Faraday's law of electrolysis. In this topic Faraday's law of electrolysis, we are going to see about Faraday as a unit, Faraday's first law, Faraday's second law. Faraday's law of electrolysis. First of all, who is Faraday? Michael Faraday was the first scientist who described the quantitative aspects of electrolysis. After his extensive investigations on electrolysis of solutions and melts of electrolytes, Faraday published his results during 1833 to 34. There are two laws, Faraday's first law and Faraday's second law. Faraday's first law. It states that the amount of chemical reaction which occurs at any electrode during electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte solution. W is directly proportional to Q. We know that Q equal to IT, so W is also directly proportional to IT. We can write that W equal to Z into IT, where Z is the electrochemical equivalent, gram equivalent weight by Faraday. W equal to gram equivalent weight by Faraday into Q, which can also be written as W equal to gram equivalent weight by F into IT, since Q equal to IT. We know that 1 Faraday equal to 96,514.8 Coulomb, which can be approximately written as 96,500 Coulomb. F equal to Ne, where N is the Avogadro number, value is 6.022 into 10 power 23 and E value is 1.602 into 10 power minus 19. Faraday's second law. It states that the amount of different substances liberated by the same quantity of electricity passing through the electrolytic solution are proportional to the chemical equivalent weights. W1 by W2 equal to E1 by E2, where E is the equivalent weight. We know that W equal to gram equivalent weight by Faraday into Q. W1 equal to gram equivalent weight of 1 by Faraday into Q. W2 equal to gram equivalent weight 2 by Faraday into Q. Gram equivalent weight equal to M by E, where M is molar mass. Then we can write that W1 by W2 equal to M1 by E1 by whole thing divided by M2 by E2. Now, based on the Faraday's law of electrolysis, we are going to discuss a problem. Question: an electric current is passed through three cells in series containing respectively solutions of copper, sulfate, silver nitrate and potassium iodide. What weights of silver and iodine will be liberated while 1.25 gram of copper is being deposited? Given that AgNO3, that is silver nitrate, becomes Ag plus NO3 minus, and copper sulfate becomes Cu2 plus SO4 2 minus, and iodide becomes I2 plus 2 electron will form 2I minus. We should find that what is the weight of iodide and silver. For this, formula is equivalent weight of copper equal to atomic weight of copper by valency factor. Similarly, we can write equivalent weight of iodide equal to atomic weight of iodide by valency factor. From that, we can find that equivalent weight of iodide. Solution: weight of copper by weight of iodide equal to equivalent weight of copper by equivalent weight of iodide. While substituting these values, we get that weight of iodide is 5 gram. Similarly, weight of copper by weight of silver equal to equivalent weight of copper by equivalent weight of silver. While substituting these values, we will get weight of silver is 4.26 gram. That's all. Question has been ended. So let us recall what we have discussed in this topic. We have discussed about Faraday's first law and Faraday's second law. In Faraday's first law, we have seen that Z equal to gram equivalent weight by Faraday, and W equal to gram equivalent weight by Faraday into Q, and we can also write W equal to Z into Q, and value of 1 Faraday is approximately 96,500 coulombs. And in Faraday's second law, we have seen that W1 by W2 equal to capital E1 by capital E2, where capital E is equivalent weight and gram equivalent weight equal to molar mass by valency factor, that is small e. W1 by W2 equal to M1 by small e1 whole thing divided by M2 by small e2. With this, I come to an end. Thank you. At last, I finished my topic. Now I am going to give a challenging question. The question is, how long it will take to produce 2.415 gram of silver metal from its salt solution by passage of 3 ampere of current? How many moles of electrons are required? When molar mass of silver is 107.9 gram per mole. Friends, try to solve this.